This is problem 5b from section 2.2. We define a linear transformation T from P2 of R to the vector space of 2 by 2 matrices with real coefficients by T of a polynomial f is equal to this 2 by 2 matrix where this entry here is the derivative of f at 0, this entry is twice the value at 1, that's 0, and the last entry there is the second derivative of f at 3. The problem is to compute the matrix of T relative to the bases beta and alpha, where alpha is this ordered basis of M 2 cross 2 of R, and beta is the basis 1x x squared, which is an ordered basis for P2 of R. Okay, now, so to compute this matrix, we first write down the elements of beta. Then we take T of these guys, and then we compute the coordinate vector relative to alpha of each vector. Okay, these will be the columns of the matrix that we want. Okay, so first we compute T of 1, so we let f of x equals 1, then f prime of x equals 0, and the second derivative is equal to 0. So then T of 1 is equal to the derivative of f at 0, second 2 times f at 1, 0, third derivative, second derivative of f at 3. Okay, so this first entry here is 0, this is twice 1, which is 2, this is 0, and this entry here is also 0. Okay, now we need to work out the coordinate vector of this relative to the basis alpha. So we write down our matrices. Okay, it's clear that this matrix here is twice this guy here, and the other coefficients are 0. So that means that the coordinate vector of T of 1 relative to alpha is the vector 0, 2, 0, 0. Okay, so now next we work out T of x. So in this case, we let f of x equals x, then the derivative of f is equal to 1, and the second derivative is equal to 0. So T of x will be the derivative of f at 0 times twice the value at 1, 0 there, and second derivative of f at 3. Okay, so this entry here is 1. This is 2 times 1 is 2, and that's 0, and this entry here is also 0. Okay, now we write this in terms of our ordered basis alpha. So again, we write down our matrices. And it's clear that this coefficient is 1, this coefficient is 2, and the other coefficients are 0. So that means the coordinate vector of t of x relative to alpha will be the vector 1, 2, 0, 0. Okay, so thirdly, we need to work out t of x squared. So this time we let f of x equals x squared. Then the first derivative of f is 2x, and the second derivative of f is equal to 2. So this time, t of x squared is derivative of f at 0 times twice the value at 1, 0 there, and second derivative at 3. Okay, so in here we put x equal to 0, we'll get 0. F of 1 is 1, we multiply by 2, we'll get 2, that's 0, and this has value 2. Okay, now we write that in terms of our basis alpha. Okay, so it's clear that the coefficient there is 2, the coefficient there is 2, and these coefficients are 0. So that means the coordinate vector of x squared relative to alpha is 0, 2, 0, 2. 0. Okay, so now we've computed the three coordinate vectors, one of t of 1, one of t of x, and one of t of x squared. So now we're able to write out our final answer, which is the matrix of t relative to the bases beta and alpha. So the first column vector we got was 0, 2, 0, 0. The next one was 1, 2, 0, 0. And the final one is 0, 2, 0, 2. And this is our answer.